Okay, 8 o'clock, let's start. Welcome, good morning, good afternoon, good evening, everybody. Good to see you all. My name is Dan Garcia. I'm a teaching professor. Hopefully, if this works out, if the technology works out, I'll be joined by my graduate student, Diana Colosi, who is working on this project. I'd like to talk to you about BJC Middle School Year 2. And I realize, and we also have Nikki Zarkab as our volunteer, so feel free to ask questions and I'll try to respond to them. I have my windows set up so I actually can still see, the chat window while I'm presenting. This should be interactive, so I'm hoping that there'll be a time I'll go through an early introduction, then we can start playing with some of the activities. Let's even start now. So I'm going to pause and have everybody load our middle school activities. So the way you do that is you go to the link up top. I'll even paste it in. It's bjc.link/bjcms for BJC Middle School. So, and I'll even add up maybe HTTP there, so the link will be clickable. Although that may be a Zoom feature where they turn that off. I remember that was an issue. BJCMS. There we go. So I'll wait for everybody to grab that. And in fact, Nikki, if you could copy and paste that second one as I continue to go and people come in late. I turned the bell off, but as people arrive late, they won't see the earlier chat. So let's make sure to get that to them. So let me put some context. I'll just get started and then you can be looking around. It's a set of, while you're there, it is a set of Google Docs with home funds. Home funds are like homework, but they're supposed to be fun. And Brian always gives me trouble about that. He says, when you ever tell kids that something's going to be fun, it never is. But I'm hoping that this is, and so we're keeping it home funds for now. And we are still developing units 3 and 4, and I'll get to that kind of near the end. But feel free to poke around and look at the kind of things we're asking our students to do. All right, but I'll put some context on the whole thing for those of you who don't know the context, but I'll go fast through this. So BJC started as a project between Brian Harvey and myself many years ago, and Tiffany Barnes very quickly was added as a trio partner of faculty kind of leading this. And then very quickly we got some funding and broadened our scope of who was part of our family. And June and Paul and Mary and Salim at EDC joined our family. Lauren and Michael were always in there early. They were former BJC teaching assistants and head TAs as part of the Berkeley class, and Jens and Bernat and others who are part of the Snap team were also part of this family. So it's a delightful team of many, many wonderful people helping to make this course happen. The context behind BJC initially was that in 2012, computer science, at least in the United States, is not even present in high school. It's present in so few people who are taking at least the formal high school course, which was APCS in Java. Not my favorite language, not my favorite course, was a very small number, about 25,000. At a time when, boy, computing was bursting onto the scene in every discipline. We needed to have more students learning it. It was still one of the smallest high school courses. And even so, it was one of the most least diverse courses in all of high school. 8% students of color, where in the United States should be about 26%, and only 50% girls, 15% girls, where it should be much higher than that as well. Let me make sure, are we recording this? Let me make sure we're recording this. Nikki, if you can make sure this is being recorded just in case.
Okay,
so we're good. Thank you. I can't see it from my side, but thank you. All right, keep on going. Let's keep the rhythm. Oops. So around 2012, we started designing a new course called APCS Principles. College Board offers these courses called AP courses, which are high school courses where you get college credit. And the idea behind it, the principle behind it was that it's supposed to be for everyone. And the goal is to share computing, with the empowering part of computing, with everybody. It was a great early design decision was made to have it be language agnostic, which means it wasn't locked into one particular language. And because there wasn't really, the way they normally run courses in the AP is they look around. For example, when they're going to design the physics course, what they normally do is they look around and they see what's done nationally at the kind of intro physics, either for majors or non-majors. They can make a decision about that around the country and kind of take the average. Take what's mostly done, and then take that. So Obviously, it's Newtonian mechanics. They don't do electricity magnetism. That's the second course. They do Newtonian mechanics. So guess what? Physics in that high school course is mostly Newtonian mechanics. And maybe they do a little taste of other things, but that's what they mostly do. So they kind of average other courses. But there was no course. That's actually how Tiffany and I got involved. We put our course, Berkeley's course, and hers, University of North Carolina, Charlotte at the time, forward as possibly a national pilot, and we got chosen. So both of us decided to team up and co-teach BJC together. So she had some ideas about games that was in her course, and we didn't, but it was okay to have a couple of differences. So we basically designed, helped co-design this course together. And the goal of this, as a third bullet you see, is the goal is maybe colleges will then start to change. So the hope was, and this is the first time this has ever been done in the AP and the College Board, is by designing a really powerful, extremely broad, by having no locked in full, by having a curriculum framework, not a curriculum, then people in the college might say, hey, well, that looks pretty good. I'll design a college course that adheres to the curriculum framework. So that was really wonderful. So it worked. It worked. The numbers are, we don't have 2019 and 2020 here, but these are the numbers initially. And you see how the numbers, even just from the first 2 years, were skyrocketing. They were just wonderful. This is the number of young girls coming in, the total number. And it was creeping up slowly, but not really making a jump. And then boom, it jumped up high. You know that this number of percentage female students should be at 50%. So we still have a ways to go. And the URM numbers, underrepresented minority numbers, Latinx, African-American, and Indigenous students, that should be at about 26. So that's actually doing much better there. Long story, we're very happy with this, and this number is looking great every year. It's been going up, so we're very happy about that. We were endorsed. We were one of the first 3 courses. There were 3 NSF funded courses to be endorsed. It was the Beauty and Joy Computing, it was Mobile CSP, and it was UTeach. And that was it. There were only 3 fully endorsed. This meant this was a long process. People on this call made that happen. I thank them for that work they put in for that. There's a long list of things you have to do to make sure that your PD is correct. You have to make sure your course hits all these marks, and it was a really painful process, but we did, and we got above that bar, and we got a big stamp we could put on our curriculum. And since that happened, many more courses have been added to the family of courses, and now there's, I think, 12 here, and then maybe even more. I think they said that the College Board said they were slowing down on endorsing, but it's been a challenge, especially with, they just made a new change. Every 4 to 5 years, it usually they say it takes 5 years to make a new course, but 4 years to kind of redo it. So just as we were launching the course in 2017, so we launched it in 2017, 2018, they started the redesign, because you can't let a course be stagnant because it takes that many years to make it happen. So you have to kind of start the redesign process. We said we just offered the first exam. What do you want to redesign it? Well, let's quickly learn what didn't work and what our teachers are telling us all across the country and across the world, and let's start. So they actually had a redesign which just launched now, and I believe the EDC folks and Brian and other folks who are at Berkeley also have shared that at this session. So that redesign has happened, and we are now kind of version 2 of the curriculum framework, which is great. But anyway, the point is there are now 12 endorsed curriculum. Really, what makes BJC special was in the first session, it's experience before formality is one of the big ideas, but this is the kind of slides that we initially kind of came up with out of Berkeley. It's more programming heavy. There were a couple of SIGC sessions that talked about let's have everybody who has a CS Principles course stand up, and we filled in these tables, and how much programming do you have? And so Mobile CSP had a number, and UTeach had a number, and other people had a number, and then we had a number, and our number was always bigger than everybody else's. And part of that came from our experience at Berkeley. Whenever we shared for students, what's the most passionate part of this course? We talked about on the bottom, we talked about social implications and balancing optimism with pessimism, and technology isn't inherently good or inherently bad. It can be used for both, depending on, like a tool. A hammer is the same way. So when we were looking at what distinguished the students, I mean, what really inspired the students, they always said, it's the last month where you let us program, where you let us just dig deep into that creative project that we get to choose for ourselves. And by the way, that's one of the distinguishing parts of APCS Principles and every one of those courses, is that the big final project, it's called the Create task, is of the student's own creation. It's so wonderful. So as we were looking at teaching some ideas like the internet, many other courses were making cool videos, and we borrowed some of those. Many other courses were, having activities where you're unplugged and you make a rope and you make a protocol. And we said, let's have a programming centric approach to that. Couldn't we not just learn about internet APIs, but actually start hacking on them and playing with them? You saw a workshop earlier, or Young Thinker session earlier, where Bernat talked about writing a talk chat, a chat, a bot. Let's do that. Let's actually hack on this stuff. And so, we scraped the web and we had ways to call the API. And so it was more of a programming centric lens than anything else. But it's still, we're using Snap. We're not, other language, by the way, other languages were using C and Python, other text-based languages. And we were finding that Snap, which we always were using from day one, it was actually BYOB at the initial time, was amazing and allowing us to do all the things that they were doing, but kids were not struggling with syntax as they were with text-based languages. So we teach recursion, even though it's above and beyond what the APCS Principles is asking for. We teach procedures as data, even though there's nothing there. Certainly abstraction is part of the course, but we think that obviously map, keep, combine are so fundamental to Snap, and we have a functional programming centric lens. No, I don't think any other of the 12 have a functional programming paradigm as their kind of central core of the way they're thinking about computing. We certainly have an imperative sequential sequence where we're drawing a lot of pictures and spirals, but we don't. We're unique in that we were kind of functional programming centric. Okay. We got a couple of grants. We partnered with EDC. We polished the curriculum even better for high school students, even better than I could have imagined. We have now reached, as last count we had on our last call was 800 teachers and professors. There are faculty around the country who are teaching our course, and it's just wonderful to have this large community of folks. We have over 1,000 people in our BJC Teachers Piazza course. This is some examples. I'll just go quickly. I'm almost done with the slides. Of our teachers, that was a group of teachers at Berkeley. There's a group of teachers in Peru. We've gone international. We had this international PD we had in Peru. This is some international PD I had in India last summer. So we're trying to have national outreach, and it's amazing to connect and learn from all these teachers for what their challenges are and how we can support them and how we need to let them adopt it in any way. And always it's the case that we give BJC to a teacher and they then adopt it to their local situation. Unless they're teaching the AP, they don't have to teach it exactly they want to. They want to bring some more stuff in that we don't do, sure, do that. But here's our curriculum as it stands. So as we were thinking about where to go next, and I hope, Brian, I represented you well from some of the calls we've had, we were thinking about, do we go to middle school or do we go to the post-BJC course? We always get confused. We call it BJC 2, or is the version BJC 2 meaning the second version of current BJC? So we're calling it the post-BJC course and the current BJC course. And I'll talk about the part on the right before I talk about the part on the left. And I'll even give Brian a chance to chime in. So Brian has really been excited about that. We're thinking about where he might take that course and maybe include getting a grant and bring our EDC team as part of that would be wonderful. It would not be APCSA in Java. It wouldn't even be APCSA. It would be this wonderful freeing thing. We would take off the shackles of the College Board and do what we believe this course, the follow-up course behind BJC would be. It's almost like what we would think APCSA should be, actually, if we had the choice. We certainly do it in Snap. Brian's very excited to do that. And he has taught for 20 years, I think 25 years, this wonderful course at Berkeley called the Structure and Interpretation of Computer Programs. And it would take a lot of the powerful ideas from that course and bring, and that was also taught at MIT. In fact, it was taken from MIT, and Berkeley and MIT were the two thought leaders in that course. And he would take a lot of those powerful ideas and bring it to that second course. We also thought, well, maybe we put a course before it because we don't want to touch BJC. We put so much effort into it, so much love into it. It's great. It's there. It's rolling. It's reached so many teachers. That's the course, and then we kind of step to each side of it. And I was thinking about the middle school course partly because I've got a middle school son and a almost to be middle school daughter, and I was trying to create, so just some history behind it. I was having a CS club. Neither of them are having any CS. Here I'm in the Bay Area. It's the hot spot of computing, and arguably with all the companies here within a half an hour drive. But my son and daughter were not getting any computer science in the class, and it was ridiculous. And here I am teaching intro computing at college, and in high school, volunteering in high school with the TEALS program, but not, I couldn't help my kids. I had nothing to give them until they get to high school. I said, let me create something. So I started taking BJC. This is the space behind it. And, taking an idea and by the way, here's the important thing. I wanted to start with an only functional paradigm. I didn't want to have them get confused with state and get confused with setting 14 variables. And half the time, somebody did an analysis at SIGSI of what's being taught in APCSA in Java, and they came up with what they saw with one particular exam, I don't know if it's every exam, 60% of 60% of the questions was basically, can you trace the code? And the code was doing complicated, interesting things. And yes, we get it that you have to understand the notional machine for that. But really, 60% of the questions are, can you just trace this iterative sequential thing, and you draw the boxes? Here's what A is, here's what the array looks like, here's what the index variable looks like, and you just trace it. Wow, is that really what we need to do? So I stepped back and said, what if I didn't have any set block? What if I had no set block in the entire first unit? What if I basically taught a functional model and it's only reporter values? But what could we do? What amazing things could we do? So I try to be as creative as I could. I try to create all these wonderful, fun projects, and then have the projects. I'd break them down. And I'd say, well, can you create this project? So that's kind of drove me, is I'd create a project and then pull the pieces out of it and say, here's the goal, make the project and see if you can do it. And I was able to help them in a workshop style. I did this every week for a year and a half. Parsons problem. So my daughter was in this course. So my wife is a programmer. My wife said to me, whatever you do, don't turn her off of computing. She said, have a great time, but whatever you do, don't kill her interest in computing. She's only in fourth grade. And you've got your son in 8th grade. You know, that's a range of 4 years. How are you going to make sure that both of our kids are happy? Well, one idea was, we don't teach to my daughter. She doesn't do it. But I said, you know, let me see if I can. So what I would do is I would give to all the 8th graders, I'd give them the challenge, but I wouldn't, I just say, you might find these blocks handy. And I did that for the first couple of you know, feel free to poke around the course. I said to my daughter, I said, let me do this. Let me, rather than just clear the stage, you know, clear the script window of all the blocks that I had in my solution and say, go, and you may find, you know, may give them a hint, you may find the mod block, you know, handy. Go click on it, click help and see what it does. I would actually, for her, make it a Parsons problem. If you're not familiar with that, it is essentially where a tornado hits your code and all the blocks kind of spin around. And so they're all there on the script window, but they're not in the right order. So, and sometimes you even can delete the values inside them. Sometimes I left them in, sometimes I took them out. So the point is, you know, if it was the innermost value with a number, I would sometimes leave the value in just to make it easier. Tiffany shared this wonderful idea during her keynote that I want to take back. I love this, where you have, by the way, I always had pair programs. I had pairs of teams doing this. So I had 10, eventually I had 10 kids, and actually it did cluster down to like pairs. So my daughter was working with the younger sister of one of my son's friends, and she's only a year older. So it actually worked out really great to have pair programming most of the time. So I had them do that. It was harder once, that was in the workshop. So we had about 2-hour workshops, you know, once a week. It was harder once they went home because they didn't really know how to work across the, you know, they weren't kind of so fluid with the, you know, Zoom, using Zoom and working on a project together. So they really didn't work together when they left my space. So it was kind of a shame that it was a little harder to do that because they were younger. Tiffany has the idea that she wants to give half the blocks to one person and half the blocks to the other and have them work together to solve it. And they can't borrow any other blocks. You have to only use the blocks in your palette, and they have to use theirs. And I think many of us on the chat, we're going to call this Barnes blocks. So the idea the two people have to work together to do that. I think that's a delightful idea. So I wanted to be, I'm a graphics PhD. I wanted to bring some graphics in there. So once I taught the functional part for units 2 and beyond, I wanted to kind of play with other things that was exciting me about the space of high school and middle school computing that I was seeing at 60. I was learning for all these other sessions. I was trying to steal, you know, from Jens and Jadga, and steal from great ideas that I was seeing all around the world. That was the spirit. Okay, I'm almost at that. So we created 4 units. The idea for each of these is that they are 1 semester, kind of 1 college semester, so half a year each. So, you know, fall semester might be functional programming when you first get to school. And then unit 2 is graphics. Graphics is going to require unit 1. And then we wanted to make sure that unit 3 and unit 4 did not require unit 2. So it was like unit 1, and then what happened is everyone goes to unit 1, but then you could actually jump to, if you only had a year, if you really liked this course, you could do unit 1 plus 3 or 1 plus 4. So that's the idea, that really 1 was required for everybody, and then you could broadenly go to 2, 3, and 4. That was the design space. In a perfect world, you'd have 1, 2, 3, and 4, and maybe we even need to create, you know, 5 and 6 for people who want to start this at the early part of middle school. Middle school in the States, at least, is usually 3 years. So maybe we'll do, you know, for 6th, 7th, and 8th grade, for roughly 11th, 12th, and 13th-year-olds, roughly. Maybe we'll go to another unit 5 and 6. But this is where we are now. We have received some funding from the Hopper Dean Foundation. I should mention that to help us put this together. What they currently exist, the curriculum currently exists as a set of Google Docs. That was really easy for the kids. They were used to that. It was easy for me to run this 10-person course there. I would give them like live sessions, but as we expand beyond that, as I use some of that funding, it's going to pay for me to make a little bit of summer money to make some more videos, so that I'm setting up each session so it's there. I need to make the answer keys. I need to make this a little bit more clean, because as I said, I was the one doing all of it. So this is my course here. So it's still early. I'm giving you a little taste of where we are this, but I wanted to make sure that people got a sense of where we were looking for units 3 and 4, and we're just starting in units 3 and 4. So let's talk about that. So unit 1 is basically up through basics, up through higher order functions, reporters, predicates, and then a lot of projects, and then higher order functions. And then let's do a lot of projects that actually play with that. And I'll show you that in the next slide or two. There's no recursion here. In fact, there isn't any recursion in any of these 3. I'm thinking for this course, this is the way I'm deciding it, to have recursion be a little bit, that comes a little later. I do want to do, maybe unit 5 would be recursion, where we go back and we revisit graphics, and we do fractals, and we maybe spend the whole time just making fractals. That might be really fun. So none of the graphics are kind of fractally based thing in which you're calling yourself. They're doing things when we actually have sequential and spiral. Spiral is part of our thing. It's wonderful. I made a big pixel library that I showed here as a Young Thinkers activity, and I'm happy to show that one as well. So I spent a lot of time playing with different ways. I actually went 3D in it. They were actually making 3D shapes, and I'll show you some of the pictures that we created in our session. So this is wide open. Each one of the things in the graphics unit was wide open for students to go above and beyond. So every single one, even from the first one, first home fun, at the last like the home fun activity would be like 8 activities. The 9th one was always go someplace fun with this, take this someplace new. And it was harder to do that when you're first learning the basics of this, but very quickly I had people getting excited about it and adding more things to it. Computational media. Jens and Yadga have created this delightful SAP course, and we've been in conversation about how could we share ideas? How could I share a project that I created, and they would share a project they created. It's just so wonderful to have this wonderful collaboration across the pond. So I'm essentially, computational media will be, I'm taking as many great ideas as I can from their session, as well as from Mark Gudsdial and from other folks, which would be great. In hardware, I have been turned on to some hardware pieces, and so I've got to bring in, the embroidery and turtle stitch. I've got to bring in 3D printing with BeetleBox. All these things are all Snap extensions. So the Finch 2 runs on Snap. In Plesmo, I have a Snap library coming. So I really want, and I'll talk about all those 4 of those hardware pieces. So I really want there to be a delightful hardware unit. And as I said, let's say you're a teacher who just wants to do media. So jump in 1 and 3 and do that. You don't have to do the hardware unit if you don't want to, but you can. And by the way, the other part of this hardware unit is if you for all these things, everything is free. The whole thing, just FYI, everything's always been free. We're never charging a dime for anything. The hardware unit obviously costs some money to kind of invest in, not to me, but to, you pay to the manufacturers of these systems. And so we're going to try to make the unit in an interesting way, which is if you only had one of them, could you do all just, so this is the hard part, the challenge. Could you do this whole unit meant for, to be a 3 or 4 month experience? Could you do it if you only had the Finch, or if you only had Plesmo? So we need to spend some time thinking about how to do unit 4, almost like we did one, here, where it's like 1 and then 2, 1 and 3. What if you only had hardware with the Finch, or hardware with 3D printing? Could you do the whole semester with that? So we're thinking about how to do that, and it may be a larger unit than others because it has this. Well, if you only have 1, then do this. If you only have 1 and 2, so we may actually have to make, in a way, 4 separate units, and then if you have all 4, then you do maybe a little bit of each. So we have to think about how to do the hardware unit, but that's still again to come. So here's our functional unit, and PS, I shared this, the whole purpose of this was to kind of share units 3 and 4, because I did share units 1 and 2 with folks at last year's conference, but people might not have attended that. So, and so I wanted to share a little bit of what we were doing there. And please, again, feel free to copy paste the link if you can into the chat for people who arrive late. So to be able to play around on your own. This is a workshop, so I want you guys to dig into this and start playing with it. Especially my big pixel one that we spend some time with the young thinkers with. So here we go. Functional programming. here's how we walk through it. Reporters, predicates. This is the if. It's actually an inline if. So making some decision, but again, it's a reporter if, not a command if. We did do whack-a-mole. So the kids wanted to do some games, and I was thinking, well, how do I do games? Well, I got to teach them whack-a-mole. So I did whack-a-mole, but actually I didn't really follow up. They went off and they could keep playing with whack-a-mole, but I did. So I'm still deciding whether I even take whack-a-mole out or do I have whack-a-mole there? So I did actually teach some, there's no sets in whack-a-mole, I believe. I should do some high score thing, but I had them playing whack-a-mole where you play with some events on the stage trying to whack Alonzo. But I'm thinking I take it out, actually. I'm thinking maybe I take it out and leave it just purely functional. So that's the one place I'm not that. Then we do map, keep, combine. In Berkeley, we teach map, keep, combine in 1 2-hour session. Here it was, you just do map. Let's just lock in on map the first week, and then let's just use keep, and then let's just combine. And the 3rd week or the 4th week of this is, what if I give you a challenge that you had to use 2 of them? And so we played with pound map at the time was the way to kind of do 2 parallel maps. And then we talked about binary and hex. The kids wanted to learn about binary numbers. They actually came to me and say, well, tell us about, I've heard about binary numbers. I'm learning about this in this course. I said, well, I'll teach you that. So most of this was driven by the kids' interest. A couple of the kids, at the beginning said, oh, we're going to learn about some kid, one of the kids had read about the Mandelbrot. Somebody had shared him a video of a Mandelbrot fractal. And they said, we're going to learn that. And so they kept saying, oh, we're going to learn that. Are we going to learn that? So actually, a lot of this was driven by, oh, we're going to learn X. And I'd say, sure, I'll teach you X. I mean, that's what I've learned in doing this is you follow their interests. And whenever they would say, I want to learn this, I would say, I'll teach it to you through Snap and do this. So they wanted to learn binary and hex. I did that. Then we made a base conversion thing. It's really beautiful to do base conversion in Snap with higher order functions. Really beautiful. The Josephus problem is a delightful problem where you go around and every other person sits down. Everyone stands up in a circle, and you make a circle. So there's no start and end, but there is a start for the first step. And that person say, "I'll stand." Like person says, "Sit." Stand, sit, stand, sit, stand, sit. When it comes around again, whoever's still standing is playing the game, whoever's sitting is not playing the game. And you keep doing this until one person's left standing, and you ask the question in advance with N people, who would be the person left standing? And so there's this little delightful unplugged activity, and the kids got good at running this. So when we had a big parent gathering where we all were having wine and cheese and everything, and the kids led that session. I was like a proud parent. Man, I literally was a proud parent, but it was fun to watch the session. It was great. I taught him some game theory, and actually I wrote a tree recursive solver to play a game perfectly. I taught them how to play NIM perfectly. We're doing binary, so we talk about NIM. These are 2 NIM variants. 10 to 0 by 1 or 2 says you got 10 matchsticks on the table, and you can take 1 or 2 matchstick away from the table at once, but only 1 or 2, and the goal is to clear the table. So I taught them that game. And then what they did was they input the way to code the game. So I actually use each sprite. It was really interesting. Each sprite knows about how to make a move, how the game is over, and how to generate all the moves. And then I made another sprite. So it's still the same sprite solver, but it really did use the OOP. I mean, I talked about a little taste to OOP, but this sprite was calling that sprite's move, primitive, and generate moves. And so then I made another sprite, make a new sprite in which you can do the game 25 to 0 by 1, 3, and 4, which is another delightful game. In fact, there's a TED video on this where you have the 25 matchsticks, but you can remove 1, 3, or 4. What's that? How do you play that one perfectly? They learned how to play that one perfectly, and also how to encode the game and how to have this perfect player. And then they actually finally made NIM. And NIM is a really fun game to solve, and it's a more general than those 2, and they were able to make that game solver. So that closed out the unit for that. That was kind of a larger project for Unit 1. Unit 2 is graphics, in which you've probably seen many of these things. These things I stole from BJC, the high school course. I stole a lot of these from other ideas. I try to give credit where I could. We made n-gons. We did spirographs. We made flowers. We made stars and string art, which I really love. We made mandalas. That came from BJC in high school. We made squirrels. We made the Ulam spiral, which is where you make a grid and then you start at 0 and you write 1, 2, like a matrix, 3, 4, 5, 6, 7, 8, 9. You kind of just write the numbers around, okay? And you do this. And I had them write them down. I taught them how to do, I didn't mention this, but in the earlier one, we talked about how to do prime numbers. And so they learned about prime numbers in that one. And then I said, what if you colored each of these that were prime? And you get this thing called an Ulam spiral, which is diagonal slicey lines. Like, why are all the primes and along a diagonal? What does that mean for number theory? It was really beautiful. We talked about tiling the plane with different shapes. I had a big pixel library, which I'm going to share in a second, and we made the Pascal's triangle, and we made a 3D horizon. I'll share some of those pictures there, and then we made the chaos game, which is this delightful game where you end up getting the Sierpinski triangle in another way, and then we made Life 1D. So it's the game of life, but played on 1D, where you sweep down on this pixels, where the next row is a function of the previous row. It's almost like if you just had looked at one row, and the game of life is, it's a plane of two things, and the center pixel is a function of the number of the 8 pixels around us that are alive or dead, and I'm either alive or dead based on the number around me of that 8. Well, this is the same thing, but on a 1D thing. So I'm looking at the pixel to the left of me, and the one to the right of me. How would that affect me, the center pixel, the next guy? And so if you sweep this down, every row is the next generation. You get this picture. So we played with Life 1D, and then we all concluded with this beautiful Mandelbrot fractal, and I took every one of the younger kids didn't get to that. They were still working on earlier ones because they were a little bit behind, but that was okay to go at your own speed. I didn't want to pressure anybody. But the older kids, the ones who were in 8th and 9th grade, finished the Mandelbrot fractal, and all of them got across the finish line with that. And that was a lot of fun. As we looked at computational media, I'm only one home fun in on that. And that was about image manipulation. And what's done is we made a green screen effect, and we had steganography, where you can hide a message in the lower order bits. So you hide a message. So you write a message in black and white, which is really fun. Then you save that, and then you can encode it in a random picture. So you send your friend a random picture. What is this garbage? It's a random picture. But in fact, the lowest order bit is the black and white message, and how to uncode, so how to encode and decode this beautiful message that the kids were writing to each other. That was really fun. It's almost like talking to your parents in Pig Latin, and they can understand you. Well, here's an image, Mom. Well, I don't know. And then if the other person says, "Oh, that's it." Bloop, you look at the lowest pixels, and that's a binary image of a message or a phone number or something. What I love that I've seen from Jens, and what I've seen all around the space of kind of what you could do with this, is the idea of pointillism, trying to make an image like George Seurat. How about making images dice? Jens and Yadka made a beautiful picture they took a picture and figured out how to turn a dice, 1 to 6. 6 has a lot of white on a dice face, and 1 has a little. So what if you looked at that and kind of mapped it and made a picture with dice, and then actually bought some dice and made a picture? That would be really fun. And how many, let's find a place we can buy, 1,000, maybe 1,000 pieces of dice without too much money, and make it images dice. Some half-tone effects. This is just recently. Jens shared this. I'm going to bring that into my course. Let's, whatever a great idea, insert your great idea here. Let's make images melt. Here's an image, and then blah, 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 it melts. Maybe it gets snowed on. Maybe here's a picture of me, and maybe I use the green screen effect to remove everything but the face, or my body. Everything behind me is green screen, as you see in this Zoom call. And maybe snow starts to fall and lands on parts of the image that's only my head. That would be really neat to do that. Jens showed this delightful mirror example, where the thing is here. And other ideas, insert your ideas here. I'd love to see some of that. In terms of, that's for images, but how about sound? I mean, you can't just talk about images and movies, but let's do sound. And by the way, let's make a lot of movies with that too. What could you do with, if you could play with sound as naturally as you can images? And I'll be frank, the Snap 6 has changed how easy this is, but also changed what I was going to do. So I have to actually go back and ray tracing. I love that. That's a wonderful idea. I have to go back now and change some of the things from Unit 2 graphics, because Snap 6 made it so much easier, right? How do I do that differently if that's the right thing to do? I'll have a deep think on that one. Thinking about sound, what would you do? So nothing's done yet, but what would I do? Maybe reversing sound. That's an easy one. We showed that in the keynote. How about frequency hearing tests? Having a thing where, it'll go up and you say, it'll go, and when do you start hearing it? When do you stop hearing it? Maybe run that program with the same headphones through your whole family and notice where the lines are. Maybe run through your whole school. Where are the lines where people can start hearing it? If you went really slowly, when do you start hearing? When do you stop? And where do those lines go? And what's the range of that? And knowing that, wow, it's harder. And maybe graphing that as for the age versus age or something. It'd be interesting to see. Sounds to color and back. Jens had this great demo, I think he showed last year, where he was able to play a note, and as he's painting, as the thing is painting, it's painting in different colors, and then it will go back and take this color. It almost looks like a snake, and the snake has different, just solid, bold colors, and then as he moves his cursor across the snake, it's playing the sound again. So sound to color and back. How about if you use sound to encode more data? So Google Tone is this delightful Chrome application where you can get in and you can share a URL with someone by just making a sound. So your computer goes almost like a modem, and anybody within earshot, if you're also running Google Tone, will say, you were just shared a URL. Do you want to open it? And you're like, wait, I just heard a random noise, but somehow you were sharing the URL. Yes, I was. So could you actually do this where it's both listening and sending messages through this random? That would be really fun. How about a reverb chamber? How about some of the echo effects you get in, Adobe Audition or some of these things where you're able to make a reverb, explain to them the basics behind what is reverb and how does that work? And could you make a delay? And how about an instrument generator? Could you make a trumpet? Could you make a violin? What does that look like? How would you even think about that? Talk about frequencies. I can't wait to show them, some of the basics behind how notes, how time to frequency is, what a Fourier transform is. Other ideas here. So happy to take this. Again, this is a wide open space and I'd love to take great ideas. If you've used this, I really would love to see, there's a birds of a feather session that I was labeling as middle school. I think it got relabeled as BJC middle school. I want to erase that to make this, it's about anybody in middle school. Let's get together. I don't want BJC to be the central theme of it. I want to talk about what ideas you're doing. What are the challenges in middle school? What are the successes you've had? So I want to, if I can, strip the BJC label off the birds of a feather session later today and have that be all middle school teachers unite. Anybody who's, curriculum designers, anybody who wants to be there in the middle school space, let's talk about some great ideas of what works. It doesn't have to be all about BJC. So I want to strip the BJC from that. Here is the hardware unit we were thinking about. Many of you have seen the Finch 2.0 demos of the young thinkers in the workshops here. That's a delightful new device that they're coming out with. I really am pleased with that. Many of us know about the BeetleBlocks wonderful 3D printing Snap extension that you can make 3D printing shapes. Many of us here on the call are part of the Turtle Stitch family, and I'm joining a recent joiner, but I'm a huge fan. It's almost like a first-time caller, long-time listener. That's where I am on Turtle Stitch. I'm happy to be part of that family. Plesmo, let me just give you a little taste. Plesmo is a set of devices, Internet of Things, but wireless, fully wireless. And Bernard has helped me last year and trying to create a kind of a library that works with Snap. So it's still very alpha beta, but when it gets more solid, you could imagine a unit that has basically all of these together. If you had, if you got a grant and you could put them together, and what would it mean to have Plesmo control the Finch, control the screen, which might control a BeetleBlocks to be a this or a turtle. What would happen to control all of these together? That would be just so amazing to have everything, tied together in one big project if you had the resources for them. Just to give a rough cost estimate, the Turtle Stitch printer I got, maybe they're cheaper ones. I got one for $800, and maybe that's $800 US. BeetleBlocks, you can now get 3D printers for in the $200, $300, $400 range. Maybe people can correct me for that one. Plesmo cost, I think, $100 for the smaller kit, $300 for the bigger kit, and Finch costs, I believe, $100. Maybe correct me on that one. So that's roughly the cost for these things. So, but you want to have not just one, you probably want to have a couple of them. Probably one, big embroidery machine, one big 3D printer. You probably want to have a couple of the Plesmo kits. So thinking about that, Arduino might be a space I haven't thought about. I haven't really experienced it as much, but that's out there. Snap for Arduino is certainly a space. I have to think about it. This is still out there. I do have a graduate student who's passionate about this. I think this might be the last slide. Yeah, I have a graduate student who wasn't able to make the call, but is passionate about this and would love, and is coming to make this her master's project. So, and she comes from the Exploratorium, the greatest science museum arguably in the world. So she's coming as one of the people who designs the activities at this museum. So my goodness, what a gift to me as I'm thinking about middle school to have somebody who's done hardware, who's played with these things in the Exploratorium by making it, kiosk friendly things, bring them over here so that we can pair together. So that's the current plan. For the next 2 years, we're going to be building really Unit 4 together. Phew, I talked too long and I'm sorry about that. Let me do this and show you some of the work that the students created. That's always really fun to share. So let me stop sharing that one and let me share another window in which I will show you some of the images we have from units 1 and 2, just real fast. PS, by the way, that I should share the link again. The link for the beginning, I'll paste it in. This is the middle school. The workshop part is feel free to play and jump in, and I'll happy to answer any questions. Let's talk about what has worked for you in this. So let me paste this here really fast. That's the middle school curriculum as it currently stands. Let me now share the screen. I think it's this one here. And let's see if this works. And there's no sound for that. Okay, I think I'm sharing the right screen. All right, so let me go here and move this window there. So this is some of the pictures that were made by the students. Let's start at this one. Okay, this is the Sierpinski triangle made in my in the Big Pixel library. This is if you left justify it without centering it. And this was in the same Big Pixel library if you assign colors to each one. I taught them about color theory. That was really fun. And we watched a lot of videos about color theory. I tried to find any YouTube resources I could. And so this is them actually plotting on the, I think it's 512 by 512, where it's kind of 0 to 256 on it from the center to the edge. And we kind of made this is one part of the color cube. And this is trying to kind of full color the whole thing. So this is 0 to red, 0 to green down, 0 to green, 0 to blue left, 0 to blue left, 0 to blue left, and then 0 to red right, and blue is up. So that's how they made that. This is the other part of the color cube, the RGB color cube. They were playing with that, having some fun with that. This is the 3D version. I basically gave them a renderer, and all they had to do was place a polygon. All you need to do is write a polygon, and each polygon is four points, and each point is just a list of 3 things. So, and I gave them how to make a polygon, and I gave them essentially how would you move a polygon. So they essentially, all they did was write a little a loop, and this was again, unit 2 has some sequential things. So they wrote a little loop to place a polygon kind of on a grid. They basically did it, this is essentially a an X by Y grid. So if the camera's here looking forward, put them on this part of the world. And so don't put them facing to the right or facing to the left, you put them on the ground. And if you do every other one, you get this beautiful kind of matrix effect. So that is that one. They also, again, play with the Mandelbrot set. And so here is the example for this is zooming into the Mandelbrot set as you do that. I think I showed some of that last year. And the kids had a lot of fun with that one. And then there's a thing called Life 1D that I mentioned before, in which Life 1D gets a rule, and I think the rule is 56 is the interesting rule. Let me see if that's the right one. 57. So each of these rules gives different pictures. Here's how the rule works. The rule is, am I white based on left, center, or right? Well, left, center, or right, that's 3 possible options. Here, one of these rules gives you the Sierpinski triangle. And I forget which rule it is, but each of these rules is different. Look at this. Half of them on the right is a little chaos, and left is this pattern. I forget, maybe a 60 something. If I keep going, there'd be 60 something. But one of these rules is this delightful pattern that has chaos and order. Not that one. Oh, if I can't find it, which is that rule? I'll find it later. People can remember the rule. Oh, look at that one. Look at this delightful kind of cross pattern. So there's some really fun things you get out of Life 1D. So that was part of the graphics curriculum. Okay, I think I'm done. Hopefully, by the way, you were playing with some of the home funds and looking at that. Let me share with you the link to the one that people have played with the most. Let me give me a second here if I get that tiny URL here. SnapCon Big Pixel. So it's tinyurl.com SnapCon Big Pixel. Here we go. HTTP tinyurl.com/SnapCon Big Pixel. So this is one of the examples that I shared in the Young Thinkers, and I think I shared a little bit in the Young Thinkers Show and Tell session. But that's a big pixel library that lets people play with each pixel and then zoom in and zoom out. If you hit Q&A, that lets you zoom in and zoom out on the pixels, and you hit spacebar to do that. So that lets you play with the pixels and tweak them. I can show you that. But let me open it up. Let me open it up to questions. This is about, hopefully you're playing the whole time. As I was talking, you were deep in the curriculum. You were looking at one of the home funds. You were loading. Often the time the home funds will tell you to load a starter project. Hopefully you were doing that, taking a look. Let's just talk. What are the things that you've done in middle school that has worked? Where should we add? What should we add to units 3 and 4? Because they're still open. The clay is very soft. I'd love to hear some success stories from people who've worked in middle school with some of this. And thank you for the 45 people who are here. This is one of the biggest workshops so far. So thank you folks for, yes.
Stop saying fun.
Thank you for that.
No, it's really important.
All right. Well, hopefully folks are enjoying themselves.
Okay, Dan, I put it in the chat, but I'm going to say it out loud because other people agreed. Let's turn this into a MOOC so we can all do it. Then we can even add more.
Interesting.
Yeah, that would be nice.
So the MOOC idea would be a self-paced. I think of MOOCs as being self-paced. Is that what you mean? Like
I
a
mean,
self-
so that so those of us who are teachers can
Mm.
experience this firsthand with you, and then we can add to it. I've been teaching a 10-year-old this summer, and I'm so interested in this whole middle school thing.
Oh, wonderful, wonderful. Well, I mean, feel free, I think I'm sharing it and view only, but feel free to take the Google Docs and so by the way, I should mention this, everything BJC has ever done has been Creative Commons licensed, which means we create something, but you can take it and add on to it. So we're adding the Creative Commons license as well to the middle school. So you right now have the access to everything we have for BJC middle school in terms of Google Docs. They're yours. Take them and add them and put them, and then give and share back to me, and maybe I'll bring them in, fold them into the main line. So
Well, can you
please
start a
take it now.
forum? Can you start a forum in the Snap forum for this particular
I
thing
love
so we can
it.
talk to each other?
I love it. What a great idea. I wasn't ready last year because it was really too early, but I think I'm ready this year. So let's do it. Let's do it. I'm making notes for myself. So share. Part of the MOOC part is that's what my goal is, to make more videos, so that what would happen is, as I said, I would launch one of the called Home Fun, can't be Home Fun now, but I would launch one of these by working with the kids for the first hour or so and then letting them play. So I would always kind of have an hour where I would, do a little bit and then walk around the room and play, and then do a little bit and walk around. So I would give a little bit, I would say, here's this block and how to use this block. And so I would do some of that, and there would be some exploration they would do on their own as well. But I want to make a little bit of videos. So if you it should be enough of a self-paced thing that I'll, teach you whatever I think needs to be taught at the beginning of a session, and then let you play after that. But I love the idea of a forum. I love the idea of trying to add their videos and kind of MOOCify this more formally. Thank you for that, Susan.
Dan, sorry to keep yelling at you, but experience before formality.
And I haven't brought that in as much. I agree with that.
Want to do some teaching? It comes at the end.
Thank you. I'll try to make sure I do some of that as well. Thank you for that.
I think you're right, Brian, at all levels, but especially at middle school. So one of the things I've been involved in is Expanding Your Horizons, a conference. It's a nationwide conference. And the idea is to hook middle school girls specifically into STEM subjects. And so they have women come teach, a whole variety of things. Like I always taught robotics, but they had a veterinarian, and we did it up at China Lake in Ridgecrest. It was fantastic. The lady that was the lead parachute developer for the Mars Curiosity Project taught a project on how to build parachutes. It was phenomenal. But, you gotta hook them early. This is blowing my mind. I wish my husband was here. He's in the Sierras right now backpacking. My question is are you guys affiliated with the Snap for Arduino? Is that out of what you're doing, or is that somebody else?
That's people on this call right here. You're one down and over working on that. So it's delightful.
He's got questions for you. We used it with primary kids because we always believe, so I teach college, but we also have kind of an ed tech company where we work with mostly homeschoolers only because it's during the day and public schoolers are locked up in school. But we believe in putting real tech. Like we don't use play tech, we give kindergartners an Arduino, right? So the question is the interface, how do they program? And so he used Snap for Arduino, but there was so much reading there that the pre-readers had a hard time. So he built functions in so they could like push a button and make things happen. Anyhow, I'd love to know he has ideas. He's got a PhD in physics, but he's like MacGyver. So he just tries everything out. So we call him MacGyver PhD. Anyhow, if there's somebody that's involved in that program, I'd love to connect him up because we just want to put this, and you got to hook them early. And middle school, if you don't hook them by middle school, it's almost too late to get them in, because then if they get, like a few of us were typing in some horror stories of middle school computer stuff, they focus on typing and PowerPoints and you just want to bash your head against a wall.
Yeah, I agree with that.
You can get this out to middle schoolers and get them hooked. Then they get on the track for science, on the track for math, on the tracks they need to be on. Otherwise they figure it out in college or something and they're like, why did nobody ever tell me this before? Anyhow.
I agree. No, amen.
I think one of the key things that you said really early on was that you were following the student's interest. And that's one of the super challenges in writing a curriculum. If you're a teacher in a class and you're not being badgered by curriculum or standards or things like that, and you happen to know stuff and you pay attention to the kid, if you're a good teacher in a class and you don't have these constraints, you can follow the kids. If you're a curriculum writer, Oh, God, which I am. They have to figure out something which, once it becomes the forced diet, because that is what curriculum becomes, and no matter what your intent is, still plays with the kids. And that's a lot harder. As soon as you write down the activities that you chose because your kids wanted them, the next person is having them not by choice. Yeah. And so the question, and that is one of the reasons why we say experience before formality. One of the reasons also why we say there are a whole bunch of words, not just fun, that you should never use. Easy, hard, fun, all of those are however that other person experiences them. They're not for us to say. Because we don't know.
That's actually one of the reasons. In the early stages of the name of BJC, there was a movement, Grady Booch gave a 60 session called the Passion, Beauty, Joy, and Awe of Computing. We threw awe out the window immediately because it was shock and awe and awe was bad. I was like, I look at it and I can't touch it. I was like, it's too big for me. I'm in awe of Martin Luther King, what he's done. I can't touch it. It's too far away. So then there's passion, beauty, and joy. Passion is internal. I can't tell you you'll have passion about something. So we threw passion out. Yeah. Because for exactly the same reason that you can't say. And I think you're right, Brian, on that. Exactly right. Yeah. Paul. So that part of the design constraints. That's exactly why we wanted to make 2, 3, and 4 optional units, so that if you had a year, you got to kind of go through to get ramped up to know how to do stuff in unit 1, and then let your kids drive 2, 3, and 4. And you might even have a teacher who's able to work it. If this is, it's really hard. These 3 students are using graphics, and those 2 students are doing media, and those 2 students are doing hardware. Like, you could, in theory, let them drive it once you kind of go. So that was part of the design for that, but it's harder.
Okay, I was able to use the Beauty and Joy by accident. It was an amazing discovery. I used computing. I participated in Fusing Computer at the Citadel with Dr. Abbott and Tiffany Barnes. Mm-hmm. And during the end of the school year, I decided to use it. And I would happen to Google and found the Beauty and Joy of computing and use some of it. And one of the kids loved it so much because she lived in California, but I teach in South Carolina. She's she wrote me a nice note and said that I was the coolest teacher she ever had because of it. So I was like, oh,
wonderful. We love these stories. Thank you for that. And that's testament to the people on this call. Thank you for that. Delightful. Other folks. Helen, I saw you nodding a lot about your experience. You want to share some of your experience with working with younger kids? I'd like to hear that.
So we were able to adopt the first few lessons in the BJC curriculum for my daughter when she was in 5th grade, because I wanted her and her class to experience this. But amazing. Like I was telling some of the other teachers in the forum, we only see the kids every other week. So it's been really, really hard. Right. But this upcoming year, because of COVID and because of the distance learning, I think we can totally go in every single week. So I'm so excited to try the BJC for 6th grade and up. Yeah. And our 6th graders, our incoming 6th graders are rock stars. These kids are our future hackers. That class.
Yeah. Well, I think it's funny. I think you're exactly right. I think if you, maybe we're Bay Area, maybe special, but I think if you looked at, all I know is I said the Bay Area kids, the 6th graders are going to be coming in the future with, because it's easy, making it easy, there are now apps, I think Thunkable or something, where you can kind of drag some things and make an app on your phone without even, so their kids are going to come in fluent with these things before they come to us. I'm thinking I'm going to get kids with a fresh thing and here's what computing is, but kids are like, come on, I know what computing is. I've got my phone, I've got my thing, so it's you have to shift where you are because the kids are coming with more and more experience. You still have to realize the kids are not coming without it, so you have to be prepared for that, but that's always hard. Yeah. Thank you for that.
The other hard part is also engaging the girls, because when my daughter was in 1st grade, the kids at that school, none of them were interested in computing or robotics. But as we're trying to build it into the curriculum, I think it's important to, like Debbie said, we got to get them early, 4th grade, even before. It's totally normal, so that by the time they are in 6th grade or 5th grade, the girls think it's normal and they aren't scared to pursue this stuff. Because that's our biggest problem right now, is trying to get the girls engaged so that it's normal and they feel confident. Yeah. So I think creative projects, integrating that into storytelling, that has helped for our school. Our kids in 5th grade last year, when I did the after school girls club, they all know what servos are. They know how to program it. They know how to calibrate it. That's totally normal for them. But when they started, they had no idea what that was. They didn't even know what a paper circuit was. So I think we need to get them early.
Well, and it is different when you pull the girls apart, especially in that age group. That's why Expanding Your Horizons is a girls' conference. And every once in a while, they couldn't like not let boys register. So like once a year, there'd be one boy whose mom registered him. And he'd end up in my robotics class, you know, because I did like a robotics before Arduino. And he was always really upset. And I thought, well, in like 3 years, this would be a best case scenario. Like you're the only boy with all the girls. But when you're in like 7th grade, that's not so cool. But when you pull the girls apart, they come up with solutions that are so different than the boys. But they don't have the confidence to go up against the boys. Some of them do. Like I was one of the girls that just said, whatever, I'm going to do it anyhow. But a lot of the girls will totally defer to the boys. And so when you pull them out into their own environment, that's when they just go crazy. It's really cool.
I was sharing, I think, with Christiana, my experience with my daughter signing up for the Young Thinkers Learning Session. I said, sit in my lap. Let's pick out the Young Thinkers activity for you for the Monday through Wednesday. And then and then the moment she said girls only, she said that one. Like she literally was like drawn like a bee to honey. Like that's the bear to honey. That was the one. And so she wanted that. So, and by the way, one of the things we had in the dynamics of my personal group of 10 kids is that it was mostly a boy-centric because my son and most of his older friends, but because my daughter was with the younger sister of one of the kids, and there was another girl a little bit older too, they became a cluster. So they always worked together. And because they were younger, if they ever couldn't do the thing the big older kids could do, that was okay. I let them go a little slower. And they kind of said, well, they were okay being in that group session because they were not the same age. They knew that if the kids were doing this one, they were their own group. And it was almost like it was a girls only thing within the room that was a co-ed room. So that also helped the dynamics of my session.
Yeah, we do. We do the same thing. We try to group the girls if they want to be grouped. We try.
Yeah, I let them self-group, but they'll group together. Paul?
I wanted to add one more context that kids, that's often overlooked, but the kids actually find fascinating. I take that back, that many kids find fascinating, obviously not all. The kids who were taking beginning Spanish at a school that I was working with, I was a very occasional visitor at this school, but the kids who were taking Spanish really enjoyed the idea of putting together a program that could conjugate a Spanish verb. And they were, it's not a heavy lift. We had to give them 1 or 2 additional tools, the library that's already in Snap for getting the ends of words as well as the beginnings of words, but 1 or 2 just special tools. And then they could solve the problem. They would look at the verb. I mean, they were learning it in Spanish class, not from me. And they would look at the verb and see how it ended, and then look at the pronoun and see which it was and pick something off a list and glue them together. And they actually took it quite far, making a little bit of gossip. It's a little hard, but many of the kids got as far as making a little bit of gossip in Spanish. And they were practicing something that for them was really a task that came from the outside. It wasn't arbitrarily imposed in this computer classes. Here's a problem you've got to solve, but something they were themselves, for another class, admittedly, trying to solve.
Got about 1.5 minutes, other folks? Last
So,
thoughts?
this is my first exposure to this curriculum.
Oh, yeah.
The Enjoy of Computing thing. But there's another version, right? There's like an older version. So I teach community college, and I always teach like the CIS 101 class.
Sure.
And I always call it the gateway drug to higher programming.
Yeah.
I just like a taste of it in there because it's a survey class. But is there a version of this for that level?
Yes, indeed. That's the original BJC is a college, non-majors college equals to kind of last 2 years of high school class. And that then has been crafted and polished by people on this call at EDC and Brian and other folks there. So I would point you to that one.
Okay.
And you can get to everything, including our professional development, through bjc.berkeley.edu. If you go there as the top point, you can get to the curriculum, you get to some PD opportunities, you can get to a lot of things from there. So that's part of our family.
And does it articulate to Berkeley, like to the UC system, or?
It is the course we taught. I mean, it has grown to add things that we haven't yet added back to Berkeley. So it's actually taken the ball and run farther down the field than we at Berkeley have. And so there are some things we do. We have to introduce Python to get the kids ready for the next course. So we have kind of a Snap and Python connection with that one at currently Berkeley, and that's an only Snap experience. But you can look at both of them, and we have some things on edX we're trying to revive that are there to use the edX small private online course model for that, but that's the idea there.
Very good.
I heard the beeper just went off, 9 o'clock. Folks, thank you so much for coming to this workshop. I hope you learned a lot. I really enjoyed having you there. 46 people, this is a huge number. I was so pleased to see you all. And there is going to be a middle school birds of a feather session. I'm stripping BJC from it. So it's about everybody in middle school wants to talk about it. It's not led by me, it's led by all of us. So birds of a feather session is supposed to be community driven. So let's have a middle school session, come to that, and we can keep the conversation going. Thanks so much, folks.